Okay, thank you very much. Can you hear me at the back? Yeah, okay. I'm really happy to be here today. I'm a biologist with Fisheries and Oceans Canada, and I'm here in place of a research scientist named Lisa Laceto, who coordinates this long-term beluga monitoring research program that I'm going to be talking about. This is really exciting for me to be talking about this because it's a coastal monitoring program. And before I got involved in this work, I worked on ships. And when you work in the coastal area, you work with people. So that's been really rewarding. And I'd like to acknowledge that the long-term program I'm going to be talking about involves many, many collaborators and people who've been working on the monitoring since I was 2 years old under the New Violet Final Agreement and the co-management framework laid out there. And in fact, for many years before that as well. So we've heard a lot today about stressors and the need to prepare for how to manage environmental stressors and multiple stressors. There's another photo here of the Crystal Serenity. So how do we prepare for these changes facing Arctic regions in the future? Well, to prepare for change and to manage it, we need knowledge. We need knowledge about the ecosystem, knowledge about how the ecosystem is structured and how it functions. So how different components of the ecosystem are connected and how they work together. And so having that information on connectivity and that knowledge base is the gold standard of where we really want to be. But we also need an understanding of variability in the ecosystem so that we can look at natural variability and then assess how things may be changing in response to stressors. And I think what we've learned from the coastal Beaufort Sea and the Canadian Beaufort Sea is that we really need to look at local knowledge and perspectives. We heard John speak today about the co-management approach to looking at beluga and other fisheries resources in the Beaufort Sea. And we've learned that the local perspective can really enhance our knowledge base, and we really need to be considering that in the work that we do. And so one way that we can look at variability and gain this knowledge is to have long-term data. So I'm going to be talking about beluga, as I mentioned. We think that beluga are a great indicator of environmental changes because they're higher in the food web, so they can incorporate change from their prey resources lower down in the food web. They're relatively long-lived. They have a circumpolar distribution, and they're associated with sea ice and ice-associated prey. And so because of that, we anticipate there to be changes in the beluga, perhaps related to their habitat and their distribution. And this could be related to their prey base and the quality and quantity of available prey resources. So somebody asked a question earlier today to John about the beluga population in the eastern Beaufort Sea. So there are 29 subpopulations of beluga whale in the circumpolar Arctic, and 6 are considered to be stable. The eastern Beaufort Sea beluga are one of these stable populations. Our last estimate was in 1992 at about 40,000 animals. And so we're just about to, in January, do another reassessment of the stock. And this will be really neat this time around because we're including not only scientific information, but traditional knowledge. We're holding the stock assessment workshop up north in Inuvik and bringing in 2 knowledge holders from each of the community who will be identified from the local Hunters and Trappers Committee. In the stock assessment now, too, we're talking about the ecosystem-based approach. Of course, we're not just looking at harvest and stock status and trends, but we're also looking at how the beluga health and how they relate to their habitat, how they respond to different stressors or how we anticipate they may respond to different stressors, as well as other aspects of their ecology. So the population that I'm talking about today, as I mentioned, is eastern Beaufort Sea beluga, so it's the green blob up there. And this is one of the largest summertime aggregations of beluga in the world. We heard from John earlier today about the important role of beluga to the New Violet culture, as well as a food resource. I think yesterday John was mentioning that country foods constitute at least 70% of the diet for most people living in communities in the north. And I think he also talked about harvest numbers and how there's about 100 whales landed annually. So as co-managers between Fisheries and Oceans Canada and the Fisheries Joint Management Committee, we work together to participate in research and in monitoring of the whale population, as well as in the decision-making process about how to manage the beluga and their supporting habitats as well. So John also talked about the harvest monitoring program for beluga whale. It's been going on for 40 years. It started in 1976. So this is a community-based monitoring program. And it's recognized as, if not the longest, one of the longest running marine mammal programs, monitoring programs in the Arctic. And so this program has provided us with many insights into the ecology of the whales, as well as trends in their abundance and other patterns that we're observing. So I just want to talk briefly about how this research program, based on the long-term beluga whale monitoring program, has evolved over time in response to different stressors. So the program started out to address concerns related to oil and gas in the Mackenzie River estuary in the 1970s, but also in response to lobbying from NGOs, from Greenpeace coming in and protesting the subsistence harvest. So the communities got together and said, we're going to generate a data set that we can use to track trends in the harvest and hopefully in the population as well. So research later focused again on oil and gas, this time in the offshore area of the Beaufort Sea. And then the research focus changed to contaminants and climate change right around the early 2000s. Up until recently, there was renewed interest in oil and gas activities. And now we recognize this need to consider multiple stressors in the ecosystem. And so to get at that, I want to talk about the scope of the beluga health program that we have running on Hendrickson Island, which is the 40-year program I mentioned earlier. This program has expanded beyond looking at a single species or stock, and now we're looking at a suite of indicators related to the health and ecology of the whales. And so this program touches on many aspects of the beluga ecology. One approach that we're really interested in right now is looking at dietary indicators. So looking at stable isotopes and fatty acids as indicators of the beluga diet and how they interact with their ecosystem. We also have veterinarians working with us on Hendrickson Island, and so they do a full health assessment looking at diseases or pathology. They examine every organ from every whale that's landed on the island. Of course, we look at basic biology and harvest statistics. We're looking at different indices of condition of the whale, and we need to age the whales for our stock assessment. And we've now moved from using teeth to a new approach using eyeballs to age the whales. And so the monitors are collecting eyeballs at all of our harvest monitoring sites. I've mentioned contaminants. We're also looking at hormones as indicators of stress in the whales. And I've mentioned working with communities to incorporate local and traditional knowledge into our beluga monitoring program. So I mentioned that this long-term monitoring program happens on Hendrickson Island. And the program started out with one beluga monitor, moved to 2 monitors, and now we've established a whole community that involves the monitors as the core part of the sampling, and then a team of scientists and typically students. We usually have a youth from Tuktoyaktuk, from the local community where John is from. We also have hunters who show up on the island. We work with our co-management partners, and sometimes different community groups as well. So we're really building this knowledge base and a team. So John showed this map earlier as well. The monitoring program for beluga whale has moved beyond this one long-term site to other areas in the coastal Beaufort Sea. So the circles in red that you can see on this map are showing where we have on-site beluga monitors. We also have places in the purple star where we send marine mammal kits, and people will opportunistically provide samples as they land whales at these sites. And then the red star is showing 2 locations, Hendrickson Island and East Whitefish, where we have an on-site research team. Okay, so I'm talking a lot about this research program. Well, What are the goals of the program? What we're trying to do is characterize ecosystem linkages to better inform decision makers about potential ecosystem responses to different stressors. And so how are we doing this? Well, we've expanded our program over time to from beyond these harvest monitoring sites, and then including scientists and veterinarians and elders and youth at the sites, to also looking at monitoring for coastal fishes and invertebrates in bycatch of other harvests. So for Dolly Varden, we'll look at the fish community from other sites. Oops. We'll do opportunistic sampling, so people in communities might phone us and say, we noticed something interesting this year. John mentioned there's a lot of chum salmon showing up, and so people will phone in and say, well, what should we do? We have some samples that we want to provide you with, and so we'll collect those fish. People will freeze them and send them to us for different dietary studies. And then we have new exploratory surveys for coastal fishes and their habitats, as well as an offshore program. So the dots on this map are showing locations where our vessel, the fishing vessel Frosty, sampled fishes and the major ecosystem components related to fishes in the offshore Beaufort Sea. And this work is really significant because prior to this study in 2012, we didn't have any fisheries information from beyond the continental shelf break of the Beaufort Sea. So we've really expanded our knowledge base. I won't talk about this, but we also do work on beluga habitat. So what we're really trying to do with this mixed bag approach is to identify ecosystem linkages between coastal and offshore areas. We know that we can do monitoring in coastal areas. It's harder for us to get a vessel out on a regular basis. And so how can we link those two habitats for monitoring purposes? And so what we're trying to do is use common indicators to look at trophic interactions. I've mentioned stable isotopes and fatty acids as dietary indicators. And so we're trying to establish a baseline for these ecosystem indicators, as well as a framework for coastal ecosystem monitoring in the Nunavut settlement region. We want to take this indicator approach and a community-based monitoring perspective. So I just want to provide one example of something that we've observed recently because of the different ways that we've been collecting information from vessels, from opportunistic sampling from the long-term program. What insights has the monitoring program provided to us? The figure that I'm showing here is it's an index of growth rate, so it's size at age for beluga. And we've noticed a subtle and somewhat variable, but seems to be a declining trend in growth of beluga over time. And so we wouldn't know this if we didn't have the monitoring data set. And it likely indicates some kind of change in the ecosystem. It might be related to changes that influence prey availability or the quality or quantity of prey for beluga. And what really makes this approach powerful is that I've been talking about beluga, but we have other monitoring programs for other marine mammals. So we're looking at ringed seal as well as marine birds, and we're also noticing declining trends in growth or condition index. So this is really powerful when we're combining multiple lines of evidence. What's also really interesting is that the communities have noticed concurrent changes. So in, I believe it's 2014, there were some changes in the distribution of beluga. This was noticed by community members and also by pilots flying over to the communities. And the beluga were appearing in Sachs Harbor and Ulahuktuk, so shown in the red bubbles here, really when they had times and in numbers that they really hadn't before. And so we conducted interviews with, the whales were harvested at these sites, and that was really unique too for the communities. So we conducted interviews with harvesters and elders, and we found that the beluga people had observed them feeding on a small silvery fish. What's really neat is that these fish were in the beluga stomachs, and when we sampled the beluga in the Mackenzie River estuary at our long-term monitoring sites, their stomachs are usually empty. So here we were able to recover the fish and determine that they were sand lances, which we hadn't found in the beluga diet before using our dietary index approach. Something that's also really neat is that, again, looking at multiple lines of information, here I'm showing the diet of Arctic char, also from Ulahuktuk, so from the same area that the community was noticing this change in whale distribution. And so the figure on your left with the big red circle is showing the proportion of different prey items in the char diet, and the red on the left represents the diet of Arctic char from 1997 up until 2013, with some years missing in between, averaged over time. And you can see that big red represents Arctic cod as the primary prey item in the stomach of Arctic char. But in 2014 and 2015, so the years when these beluga were appearing at different times, you can see that the pie chart is completely different. One of the blues up there is representing sand lance, contributing in greater numbers to the diet of the char. And the yellow is also themisto, an amphipod. So again, multiple lines of evidence from community-based monitoring, from local observations, kind of pointing to some kind of change that's happening. So I just want to make a connection to our offshore program. At the same time that these changes were happening in the community, the condition index of beluga was lower in the 2 years that we were seeing this pattern. And so what I'm showing here is an echogram from a fish survey in the Beaufort Shelf and Slope in 2012 and 2013, the first 2 years that we went farther offshore. So the blue dots are targets, and when we send nets through to ground truth, what we were finding was that picture, which was basically everything was Arctic cod in that pelagic layer and as well on the bottom. So dense aggregations of Arctic cod. But when we went back in 2014, this is the picture that we had. So the distribution of Arctic cod biomass was just, it wasn't there. We weren't sampling the fishes. In fact, when we went into some of the coastal embayments, we were getting a thin layer of targets on the top of our echogram that was actually themisto, that amphipod. So something was going on, whether this is some kind of natural variability. It's possible. We wonder if it's 2012 was if you recall, the record sea ice minimum, and we think that there may have been a recruitment failure of Arctic cod in that year. And that we're seeing these changes in beluga distribution and diet because they're adapting to a new prey resource. So I'll just give that one example. The other thing that I wanted to say is that I mentioned we're looking at local perspectives. So part of our research program involves identifying local indicators that people in communities can go out and monitor for and provide us with information on changes in the ecosystem. So much of this work is related to boat-based observations. Hunters will go out and they'll take observations. They'll either be interviewed when they come to shore, or we've developed an app, which is that picture in the bottom, so people can be out on their phone and make observations about beluga behavior, use of habitat, if they're seen feeding, and different things like that. So we're building this information base from local knowledge. We've also worked with communities to develop different indicators, and we're in the process of assessing them. So these indicators are related to beluga health, diet, their group composition, habitat use, and even changes in how food is prepared factors into some of these, into some of our indicator development. So I just want to show, this is a poster that we made. People often ask us, where do the samples go? Because people are sending samples down to where I live in Winnipeg. And so we developed this Life of a Beluga sampling program, and I just want to show that our sampling is not linear anymore. It's not a single species. We're looking at different aspects of the ecology of the whales, disease, response to stressors, ecosystem biomarkers, and aspects of their physiology. So it's the scope of the program is wide and it's fairly comprehensive. And just quickly before I finish, I made this slide last night. How is this work fitting into this ecosystem approach? Well, DFO has identified the area, which is the Beaufort Sea Large Ocean Management Area, which is the marine portion of the Nunavut settlement area. So this is what we've been talking about. We've prepared ecological overviews for this LOMA, as well as we've heard about 2 marine protected areas that are, one that's designated, one that's in the works. So we've described the ecosystem at these different scales. And so we've established ecological objectives for the 2 marine protected areas, as well as for the large ocean management area as a whole. And this is where we are right now, at least in our research program, is working on monitoring, reporting, and refining our indicators, so the assessing part. And someone mentioned yesterday that this part is iterative, and that's certainly where we are in our thinking. This is beyond the work that I do, but valuing the ecosystem, I think we've heard about certainly the value of country foods. And so, as I mentioned, different ways that we can manage this ecosystem are through creation of marine protected areas. We have an integrated oceans management plan that was developed through the Beaufort Sea Partnership. John mentioned this earlier. And what do we provide as scientists? Well, we provide information for stock assessments, samples, data, and data products, models, primary publications, mentioned these tools to support marine protected area planning and management. And so I think I'll leave it at that, and thank you very much.